We can see the dust come in on the gust front ahead of the spring storms. When the winds blow out of the southwest and they bring the dust out of the desert, we can see it come in on the air. And then it's readily observed on the snowpack. The snow turns red or brown depending on the source area. And it's easy to see the dust on top of the snow. In our field observations, we've seen the effects of dust melting snow faster. And we've, in previous work, shown that dust causes the snowpack to melt out about a month early. So our next question was, well, what happens basin-wide? And what are the effects on runoff in the Colorado River?
So the Colorado River is the lifeblood of the American Southwest. It supplies water to almost 30 million people in parts of 7 different states. It irrigates 3.5 million acres in the American Southwest. Without the Colorado River, the American Southwest really is no more as we know it.
To accomplish our current study, we used a hydrology model which simulates the energy and water balance over the snowpack for the entire river basin. We compared 2 scenarios, one that represents current conditions, current dusty conditions, and another scenario which represents much cleaner conditions that existed before human settlement in this region. The effects of dust on snowmelt are actually readily observed. In fact, commonly we will scrape the snow surface free of dust and come back in the afternoon, and the dusty snow around that little patch will have melted faster, and we see a sort of elevated patch of snow where we scraped it clean. So one way we observe dust in the field is to dig snow pits, and we can see in those snow pit walls horizontal dust layers, orange or brown layers, that correspond to each of the dust deposition events that happened during that snow year. Our model results indicate that snowmelt has advanced on the order of 3 weeks. We see a 3-week shift in the peak of the snowmelt hydrograph. And because of that shift, we see on average a 5% reduction in river flow as measured at Lee's Ferry.
So the implications of the study are interesting with respect to what is happening now and what will happen in the future. With respect to what's going on now, I think that there's the opportunity potentially to recover some of the loss in water that's here by better land management in the American Southwest. Looking forward into the future, I think this study gives us some hints that we could lose yet even more water if we're not careful about how we manage those lands. One of the findings of this study is that on average we've lost 5% of the flow of the Colorado River, 750,000 acre feet, 750,000 acre feet. That's twice what Las Vegas's water right is right now. It's about half of what Arizona takes down through its Central Arizona project. It's twice what the city of Denver uses for water. It's a large chunk of water.